to start Leetcode question and we will understand how to implement it. Okay, so the question is 2279, the maximum bags with the full capacity of rocks, in which it is saying that we have some bags, right, and which is n number of bags starting from 0 to n minus 1. So you are given two 0 indexed integer array and the capacity and rock, right? So the capacity and rocks are two integer array, okay, and the ith bag can hold a maximum capacity of I rocks, and currently rocks of I contains what, right? Rocks of I, and you are also given an additional rocks, right? The number of additional rocks can place any number of bag, okay, and so we have to return the maximum number of bags that can have full capacity after placing the additional rocks in some bags. What we understand means, in this problem we are given two rocks and capacity of the same length n, which represents n bags, and for each bag I has a maximum capacity of I, and currently contains what? Rocks of I, right? So this is the capacity that we are talking about. This is capacity we have, and this is our rocks. And how many rocks we can store? That is additional two rocks we can store. So we also given this two rocks, right? Additional rocks which we have to fill the bag if they are required, right? So if we talk about this example that we are seeing here, right? So the bag has capacity what? 2, right? The bag capacity is what? 2. The first bag has capacity was 2 here, right? And currently contains what rocks? 0 rocks contains. Thus we can fill it 2 additional rocks here, right? We can fill here. And however, the last bag has a capacity 6 here, right? But currently contains what? 3, right? Here we can store 3. So thus we can't fill it since we have only 2 additional rocks, right? 2 additional rocks we have to store, but it requires 3, right? So capacity will be get lost, right? Obviously. So this should be go to what? This position, correctly. So we want to fill as many as possible, right? But the question is how many bag can fill, right? How many bag we can fill? That is a question, right? So let's understand the approach first. What approach we will follow here? The approach is given is greedy approach, right? So what is intuition behind the problem we have is, since we want to fill the bag and thus we only care about remaining capacity of each bag, correct? We have given capacity, we have given current value of the bag, right? But what we have to care about, that is the remaining capacity of each bag, right? So bag 1 has capacity 5 and currently contains 3 rocks, right? Bag 2 has capacity 20 but currently contains 18 rock, right? Like that. But remaining is what? Remaining is what? Currently have 3 but capacity is what? 5. So if we talk about this scenario and it is saying capacity, right, means 5 minus 3, current what we have? Current capacity is 5 but he is holding what? 3, means he can store what? Remaining capacity is what? Remaining capacity is nothing but 2. So we have to focus on the remaining capacity. If you similarly, if you talk about this one, right? So bag 2 has capacity what? 20, but he was currently storing what? 18, means we can store what? 2. So remaining capacity is what? 2, right? So it takes the same amount of rock to fill both bag. So for us there is no difference between two bags, right? They both have 2 remaining capacity that we have talked about here, right? So therefore we need to calculate the remaining capacity of each bag I, and by letting its capacity of I, we have to subtract what? The number of rocks, right? Number of rocks. Okay. So it currently we have rock of I, as you can see here, right? So remaining capacity of each bag will get from what? We can get from here, right? The capacity of I and and rock of I, right? That I have told you, right? The remaining capacity of bag is what? Capacity of I minus rocks. So this is our formula. Okay, this is our formula. We have to take care of remaining capacity. So as we would like to fill as many bag as possible, we will fill the bag with the smallest remaining capacity, right? So therefore we should sort all the bags by order of remaining capacity, right? What we have to do, we should sort the bag by doing the order of remaining capacity, and then we will start filling them, right, by using additional rocks. First we will sort, and then we will start filling the additional rocks from the bag with the smallest remaining capacity, which has the smallest capacity. From there we will start filling that. So this process stops when we don't have enough rock to fill the current bag and can't fill the bag, right? So those things you have to see, right? So so what we can do, uh, is why we are doing actually, right? The process stops when we don't have enough rock to fill the current bag. Since we sort by remaining capacity, all subsequent bags will have no remaining capacity than the current one. So if we can't fill the bag, it means we can't fill any of the bag after it. Gotcha? Let's understand. We are talking about, we have given stones, right? We have given a stone, we have given capacity, right? And this is our additional rocks, correct? So currently what we have, 0 2 4 4, 0 2 4 4 3. What is the current capacity we have? We have 2 3 4 5 6. So what we have told, we have to define, we have to take a remaining capacity. What is the remaining capacity? We have taken the formula capacity. First we will take capacity, right? Capacity of I are minus what? The stone, rocks, stone, current stone value, right? Stone of I, and whichever will come, that is our remaining of I. Okay, so this is our formula that we will use, and we will make what? This remaining capacity array. So 2 minus 0, 2 minus 0 is what? 2, that is okay. 3 minus 2, right, that is 1. And similarly 4 minus 4 0, 5 minus 4 1, and 6 minus 3 is 3. So this is our current capacity of the bag. Got it? Now we have now a remaining capacity, so we will talk about only this one. Okay, so what we should do, we will do, you can see here, we have not did here sorting, correct? Now we have did sorting, right? So we have sort this bag, remaining capacity of the bag, and then you can say, by sorting the capacity we have to fill them by additional row. Now we will use start filling this one. Now full bag is not here currently, right? So what we will do, we will see, we will current bag, the first bag needs 0 extra rock, so we cannot fill here, because it is 0. So we have to move to next here, right? So and that's why we can say full bag is 1, right? Now if we'll talk about the second bag needs 1 extra rock, right? Because we have 2 additional rocks and we fill it by moving, then we have to move to next, right? So if you'll see that this is capacity is what is the capacity? So current bag, if you'll talk, see here what we have, 0, then we have moved here. Now we will see this one. So there is capacity, remaining capacity is 1. So what we can do, from 2, previously we have 2 rocks, right? So what we can do, we will take 1 rock, right, and we will do the full bag, right? So what we can do, now we can put here. So this is full, right? So now this will become, what? This one, right? Now we have came here at this, right? So one bag we have added here, additional rocks we have put here. Now the bag is what? Full with 2. So we have two, we have 2 additional one, but we need only 1, right? And that we did here. Now if we come to the next bag, right, the capacity is 1. So what we'll do, we'll take 1 more here, right? We are taking 1 more here. So we have 2 additional rocks that we have used this place and this place, right? So you can see we have used what? These 3, right? So that Now it is full bag is 3, and that's why when we come to next is 4 here and 3. So we do not need to move to here, because fourth bag needs extra 2 rocks, and we run out of the rock. We don't have here the rock, we don't have, and so we have to stop the iteration here, right? We have to stop iteration here. Okay, and we will return 3, because now we will count from 0 0 1 2, right? Total is what? 3. And so our job is done. So we will return what is total bag we have. We will give the maximum full bag is 3. So what is the question, what is the answer here, right? We have to move one by one, right? But before that we have to find out the remaining capacity, right? And then we'll check the capacity. If capacity is equal to that, then we will move, otherwise we will do minus, right? So let's see here. First we will do to calculate the remaining capacity of each bag, and we'll store value in array, that is all remaining capacity. And starting we'll take full bag is 0. We'll take two things, remaining capacity, right, to calculate the minimum capacity of each bag, right? And we'll store the value in array. What is the array? Remaining capacity, as we have seen how we have calculated the remaining capacity. And we'll take initial value, full bag is 0, and this is our answer that we will return in the final, right? As you can see here, what we are returning, this one bag, this is we are returning. So step 1 will take the initial set full bags, and this will we will return in the last, right? And what we have to calculate, we have to calculate remaining capacity in the first step, right? So after getting the remaining capacity, right, what we can do, we can sort the remaining capacity, right? So next step we have to sort the remaining capacity array, and then we will move to step 3. In the step 3 we will do iterate over the sorted remaining capacity. We will iterate from 0 to n that we are traversing, right? If for each value, for each capacity, what we will do, we'll check with the we will check, right, and check we have enough additional rock to fill. If the rock is done, right, so we will not move next, we don't need to move next, right? So that we have to fill in that. If so, the increment full bag by 1, we have to increase 1 by 1, we have to do increment full bag by 1. Okay, and then and decrement additional rock by capacity. Whatever the capacity will have, we have to do plus plus, and here we have to do minus minus, right? And then we have to move on to the next bag, otherwise we will stop iteration if you don't have additional rock, right? We will do break here. Okay, so let's understand the implementation section. Starting, we have to take capacity, right, the length of the capacity that we have taken, right? This is capacity, this is rock, and this is additional rocks, right? So total capacity is what? Capacity length is n. So and full bag is what? 0. Now we will take one remaining capacity, that is we have taken here remaining capacity, and this is the length of the same length of capacity 1, right? So what we'll do, we'll make a for loop I 0 to n, and then we'll set the capacity. How we'll set the capacity? We have to use capacity of I minus rock of I, and that is what remaining capacity is here. Now we'll do array sort, the step 2, right? This is step 2. So this was our step 1, and this is a step 2. From here to here we have a step 1, and this is our step 2, right? First what we have did, we have created a remaining capacity, and we have initialize the remaining capacity by capacity of I minus rock of I, correct? And then we have sort the remaining capacity. Now step 3 will do from here to here, right, last, and this is step 4, and this is step 5. Okay, so step 4, what we have to do, we have to start again the loop I equal to 0 to n, and then if we'll check the additional capacity is greater than or equal to the remaining capacity of I. Additional capacity is greater than or equal to remaining capacity of I, right? So if the remaining capacity is more than equal to, right, what we have to do, we have to decrease additional rock by the remaining capacity, right? if we talk about, if initially what we have, additional rock is 2, right, and remaining capacity is what, we'll take greater than equal to, we can take 2. Okay, so remaining capacity is 2 and this is 2, so this is greater than equal to, means it is true. What we will do, we will decrease the remaining capacity. Now remaining capacity is what, additional rock is what, 0, and remaining capacity will remain 2 only, right? No, we will do plus plus, right? So but we don't have to worry about the remaining capacity, right? We have to increase the full rock, right? So only we have to decrease this one, because this is additional bags, we have to do minus minus here, and then we will increase, right? So similarly what we are doing here, we are doing additional rock minus of the remaining capacity, and then we are increasing bags, because we have to return this one, we have not returned to the additional capacity, we have to return full bag. If that is not the case, right, if it is if additional rock is not greater than equal to remaining capacity, we will break here, correct? We will break here, we will not move to anyone, and this will continue, this loop will continue till what, and then we will return full back in the final, right? So now understand the capacity, complexity analysis we have to do, right? So actually you have seen that we have n size of the input array, that is capacity, right? And we are doing extra thing is what, we are doing same, we are moving to 0 to n only, but we are doing extra thing at a step 2, right? That is we are doing sorting, right? So time complexity, why we are taking o n log n, because this is what we are doing here, right? We use remaining capacities to store the remaining capacity of each bag, and it takes o n time, correctly, because the array size is what, n, but we are doing sorting, right, that in the step 2, and that requires o n log n times, right? And we iterate over the sorted array, we iterate over the sorted array remaining capacity, right? We have did sorting, and then we have did the sorting, and then we take what, o n time, right? So to, if we'll do sum, right, o n plus o of n log n, correct? If we'll do that, what will come, this will come, n log n, correct? So that's why they are getting, and we are taking extra space to store the remaining capacity, and that's why it is not constant, it is coming o of n, right? So guys, please let me know if I have helped you here to understand. So please help me in growing the channel, and please like, subscribe, and comment here. Thank you so much. If you have any doubt, please comment here. Thank you so much.